think we're right on the front. Relative extrema test. Yeah. That look about right? Okay, here I go. Again, I apologize if I'm going too fast. It gets to the point where this isn't productive to say, hey, you need to slow down here. Okay, so please, I beg you, read carefully for local versus extreme versus absolute. If you go off on in the wrong direction, you probably are going to lose points on a free response. If it says, you know, find any local extrema, justify your answers, that's first derivative or second derivative test. It says find the maximum. That's absolute extreme. Okay? A function has an extrema if the first derivative changes sign in any fashion. If on a calculator problem, it's pretty common in a free or multiple choice. On multiple choice, they'll say, here's f prime. How many extrema does it have? Please set your window accordingly. Again, I'm kind of mixing up all my A, B, and B to C mistakes, but I had people show the whole derivative in their calculator, then calculate, or count the x-intercepts. Make sure that you actually set a window if they give you a window. Always use it, okay? Just so we're clear, the first derivative test, say what needs to be said, not more, not less. F, or whatever the function is for the problem. I've talked about this, but I'll say it again. If the problem is h of x is this, but your conclusion reads, there's a min because f prime changes, you're out. They don't say, oh, he meant h. They say it was supposed to be h prime, you used f prime, you're done. Okay? So please use the variable that they give you, not just generic, always f prime. It doesn't work that way. Okay? Next, a max of x equals c if f prime changes positive to negative. The best, just do good calculus, but don't try and overachieve on the AP test. Sometimes students will lose points because then they think, I'm going to really nail it. And they'll say, f prime changes positive to negative, increasing to decreasing. If you add that increasing to decreasing, well, what was the last subject in the sentence? The last subject was f prime. And if you say f prime changes positive to negative, increasing to decreasing, doesn't that imply that f prime is changing, increasing to decreasing? You lose points. You just lost that point. You had it, and you said too much, and you gave it away. Okay, so say what needs to be said, and not more. You're underachieving. You're not overachieving if you really kitchen sink it, and you throw everything at it. Okay? They have 100,000 papers to grade. Say exactly what should be said, and that's all. And leave it alone. Okay? F has min at x equals c because f prime changes negative to positive. Okay? I'll say this also. Make sure your subjects, if you don't get mixed up here, it's not f prime has a min or f has min because f changes. Okay? F has a min, prime changes. Yes?
Just in general, when you're like explaining these, as far as like wording goes, can you like read it at all? Or
so I have always said that it's okay to use BC, and I would say, and POS for positive and negative, all that to me, I've been told fine. I don't know about that's crazy. Let me talk to Miss Kennedy about that. I know, I was just talking to Harper about this. She got dinged for writing BC instead of us. I don't know if that's an AP thing or that's trying to teach you proper calculus. Oh, that I know. That's great. I'll ask Shannon and I'll get back to you, okay? That's good. Her job is to teach you very well for more. Using the second derivative case, Or for lots of reasons. First of all, it tells you concavity. Function is concave up if f double is positive. Concave down if f double is negative. Would you please, on a fundamental theorem kind of question, which is the most common question of all AP questions, you've done a million of them, whether you realize it or not. If this is f prime, and I say 1, 2, 3, 4. If I say, where is f concave up, please be clear in your reasoning process. Do you agree concavity is about f double? There's no f double here. You're making conclusions or inferences, and you need to communicate those inferences. So you'd say something like f is concave up on 0 to 1 and 3 to 4. And your reasoning, to be sound, first of all, answer the question. F is concave up on 0 to 1 and 3 to 4. They do not care about the endpoints in such a question. If you use parentheses, you're in. Brackets, you're in. Okay, they don't worry about that. Because, now, to me, good calculus would show a couple things. Because, first of all, F double, which is equivalent to slope of F prime, is positive. Okay, to me that is necessary calculus because it's making an inference to get that. Right? So make sure you communicate your calculus. This I hope after how many fits I've thrown over this, I hope it's done, but we'll see. A function has an inflection point if f double. Would you please write f double equals 0 and then put a big old X through it. If f double changes sign. Yes, you start looking where f double is 0 or is undefined, but then you verify with the sign test that it's also changing sign. Okay? It is sometimes the case on a multiple choice problem that you have to gather information about the second derivative from a table. If, for example, if I said something like 0, 1, 2, and this is 2, 4, A, if I told you f double is positive, then what could you tell me? Let me say f prime is positive and f double is positive. What could you tell me about A? Give me one thing you could tell me about A. It's greater than 4 because f prime is positive. It's got to be increasing, so I know it's greater than 4. That might rule out a couple of choices. The second derivative part is a little harder. Okay, second derivative here, rather than think, so if you're visual, it might pay off to graph it and say, okay, I need to choose a concave up thing. But you might also think second derivative is change in the change. Now here, the change is positive 2. So the next change, if this is second derivative positive, then aren't the changes or derivatives increasing? So shouldn't the next change be more than 2? So you would say, besides having to be greater than 4, I also know it has to be greater than 6, because the next change has to be more than 2. Okay, you with me? That's pretty common. All right, the second derivative test for relative extrema has 2 conditions on it, or 2 parts to the conclusion. A function has a relative max at x equals c if f prime at c is 0. It's worth noting that the second derivative test doesn't work for undefined points. Does not work for like sharp turns and cusps. The second derivative test is a wash there. I can't prove anything there because if the first derivative doesn't exist, the second derivative doesn't exist, and there's no way to say the sign of the second derivative, it doesn't exist. All right. So the second derivative test only works for horizontal tangent. Are you with me? Okay, so if the first derivative is positive and the second derivative, the first derivative is 0 and the second derivative is, what would make a max if the second derivative is positive or negative? Negative. So make a little picture, it helps. Okay, and both of those need to be second. function has relative min, I think you get the idea. First derivative positive, second derivative positive. Okay? First derivative 0, second derivative positive. If you get a differential equation, derivative, it's a function of x and y, something like this. We've done this a lot. Then you would never use, if it says where's an extrema, you would never use the first derivative test here, some kind of two-dimensional x versus y sign test. You don't do that. It's use the second derivative test here. Not first derivative test. You with me? Okay. Moving on. Absolute extrema. This is also guaranteed to be somewhere around a free response. It's a big idea of calculus. When you're given a continuous function on a closed interval, there must be an absolute max and min. It has to have one. It doesn't have to be unique. It could happen more than once, but it has to have one. The absolute extrema must be at endpoints or critical numbers. I was taught, and I've taught you, to make that your thesis of the problem. That's the first thing you write. Absolute extrema are at endpoints or critical numbers. The endpoints here are given. I don't know if you need to restate them, but the critical numbers. This is a common lost point for high-level students like yourselves. Critical points, people, especially if it's calculator active, they sometimes will just say, critical numbers, x equals blah. That won't do, okay? When you find the critical numbers, you must show where the critical numbers come from. So it's something like critical numbers or critical points, both are fine. You need to say, oh, the derivative is 0 or undefined at x equal blah. Or the birth rate equals the death rate at blah. It could be a lot of different things. If it's a word problem, application kind of thing, then keep in mind that the equations they give you might already be rates of change. This, again, is more of a lower level kid than you. But if, for example, it said the population of the penguin population has a birth rate of blah, 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 and a death rate of blah, 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 would you then take derivatives on those? No, they're already rates, okay? So they're looking for you, or more likely a Calc 1 student, to say, oh, I got to find B prime because it says find the rate of change. They're already rates. You don't take derivatives. That's silly, okay? So if, for example, I was looking for an absolute max here, then rather than say f prime is 0 or undefined, I might say the net rate, birth minus death, is 0 or undefined. Or birth equals death at, to justify where my critical numbers were coming from. You with me? Okay. After that, it's pretty common that you then find the amount at each time using fundamental theorem of calculus. When you go to, say you are given f prime or some kind of rate and an initial condition, okay? You could either just define amount at any point by doing some kind of dummy variable, something like f at any point x is f at 0 plus the change from 0 to x of f prime. Even that without a dummy variable would be okay. If you do that, then every time you make a calculation, you wouldn't have to show where your work came from. So for example, say my candidates were f at 0 and 1.3 and 3. You with me? Then I wouldn't have to, if I wrote this, then I wouldn't have to show f at 1 is f at 0 plus the integral from 0 to 1 every time. And it saves you some writing. Although, you could definitely show each one separately, and that's fine too. Are you with me? Are you with me?
What was the word after define?
After what?
Define.
Amount at any point. Sorry, AMT, I didn't think. Okay. So say we look at this case here. At time equals 0, there are 80 people in the art show. People that are at a rate of, you see it, leave at a rate of that. Now, I would underline these are already rates. To me, that word rate is a word I would look for. If it shows open for 10 hours to the nearest person, that's one of those where some of you have lost points for not rounding appropriately. I personally think it's best to show the decimal answer, then round it, but please underline that. If it says round to the nearest whole number, round it to the nearest whole number. If, however, in part B they asked you to round, in part C they didn't, then don't go back to rounding, okay? It's so common that people were asked to round in B, so they think from now on I'm rounding. No, round when they say to round, and don't round when they don't say to round. That's all. You with me? Okay, so if I were saying what is the max, that to me is crucial. It doesn't say find a local max. It says what is the max. Is that absolute max or relative? Absolute max. So I would say absolute max is that an endpoint or a critical number? The endpoints, if you want to state them, you can. It says, I think there's a defect in this problem. I can't remember what it was. But do you agree the endpoints are times 0 to times 10? You with me? Okay. The critical numbers. How would you about finding them and explaining how you found them? Think of what's the net rate? E of t minus L of t. Now, some students don't name it, and that's fine. Some students like to say, you know what, I'm going to let the amount of people be A, and therefore, wouldn't E of t minus L of t represent A prime, the change in the amount of people? Now, that's not required. That's just an approach, and if you like it, great. But if you don't, that's fine. But either way, wouldn't you say a critical number is where the rates are equal to each other, because everywhere else, one's bigger than the other, and so it's probably increasing or decreasing around that point. So I would say my critical numbers come from this, or when they're equal. You wouldn't have to say both. You could say one. Either one is fine, but you definitely have to say one. If you found that, this comes out clean. What do we got there? 5 halves t. I could have sworn there's an error in here. 20 minus 45ths. Does that look right? Yeah, okay. So 8's a candidate. You with me? Okay. So how do I find the amount of people at the amount of people at time 0 is given as 80, yeah? Would you generally define amount in a fundamental theorem way, or would you just find both and show it? In this case, there's only 2, so it's not like you're going to do a ton of work to show both. Do you agree? Okay, so let's just say I find the amount in 8. How would I find the amount in 8? When you're given rates of change and you want amounts, you use an integral. Start plus change. Remember, start plus change, and change is the antiderivative of the integral of a rate of change times time gives you an amount of change. So we're looking at a starting amount plus the change in the amount from 0 to 8 of enter minus leave. And we could calculate that, and if we wanted to, and then the amount at time 10 would be the same, but from 0 to 10. Do you agree? And then we decide based on what's the greatest. Very common question. Pretty much guaranteed to be. You good? Okay. Related rates, I'm not going to even. It's used to find change with respect to time rather than each other. So you're differentiating with respect to time. Ms. Cannon teaches this as well as anybody in the world, so I'm not going to go over that too much. Okay, mean value / relay. It's been a while. What's the big idea? Mean value theorem. If you were to play and you're playing all normal words, what is mean value theorem? Under certain conditions, there's a place where average rate of change equals instantaneous rate of change. Average rate equals Instantaneous rate of change. Again, under certain circumstances. The circumstances that it's got to be continuous on the closed and differentiable on the open. And those need to be stated when you, on a free response question, that they're met. If you read a question that says, so that's what this is basically saying. This is the instantaneous rate of change, and this is the average rate of change. And if you read a question that says, must there be a C such that F prime at C is blah, 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 then you should right away go to MVT as your first thought process, okay? Relay is a special case of MVT, not so much where the endpoints are different, and there's got to be a place where the tangent slopes like it, but the endpoints are the same, and that then would mean that either there's a min or a max, or two, or both, kind of thing. So relay has that same first two conditions, continuous on the closed and differentiable on the open. But for relay, it's also got the extra condition that the endpoint y's are the same, so that the average slope is 0. Right? If you didn't say relay, if you just said, you know what, I just did MBT, you'd be fine. No problem. Okay? All right. And then optimization. This is never, from my experience, been a free response question. It is usually a multiple choice question, usually of the analytic geometry variety, something like, what's the greatest rectangle that can be inscribed between the axis and the parabola? Ask yourself, what are you trying to optimize? Write an equation for that in terms of one variable, sometimes by substitution, and then optimize the heck out of it. Derivative goes positive from negative. You with me? This is more of an error. This is more of a focus in college. Optimization is done more in college than on the AP test, especially at business calc, which is the biggest problem. Optimization. Make sure in these that you're not differentiating with respect to time. You're just saying, how does the area change with different x's? So it's dy dx or dA dx. There's no time component to optimization. Sometimes people think because they're all word problems that related rates and optimization are the same. They're not the same. They're very different. Time. Okay. And then motion. This will be continued again throughout this whole week, but for derivative applications, motion. The average velocity is change in position over change in time between 2 points, an interval. Okay? Instantaneous velocity then is to say, you know what? How in a microsecond, how far did you go and how long did it take? That's more of a microscopic delta x over delta t. So it's the derivative. Velocity is the derivative of position. Wait. The danger for you guys is to think that's obvious. That's not obvious. You need to say it. If they ask you for velocity, you need to say velocity is the derivative of the position. Then find it. Don't just out of nowhere throw it out. Okay? Acceleration is the change in velocity over change in time. Now I'm saying average velocity here and here. But one of the hardest parts for students to get their mind around is that average can actually be two totally different approaches. If they gave you position and they wanted average velocity, wouldn't that be position change over the time frame? Yeah? But if they gave you velocity and they wanted average velocity, then what would you do? That's an average value of what you have. And so it's an average value. So when you think average, your mind can definitely go to one of those two things, but don't get locked into, oh, average means this, when it might be more the average value. Okay? Average acceleration, assuming you were given velocity, it would be change in velocity over change in time, but at an instant, the acceleration is the derivative of velocity or the second derivative of position. I know you've done that to death. Speed. Speed is the absolute value of velocity. So, imagine I gave you this here problem. I told you this is the position at time, and I gave you this. 1, 2, 3, 4. Assuming there's horizontal tangents at 1 and 3. When is speed increasing? Now you could do this analytically, but think visually. What speed? If I were to grab, oh, never mind. If I were to, what's velocity, first of all? Slope, right? So here's slope, maybe I think I wanted, I think I wanted this is what I meant to say. If I said this is the velocity graph, this is what I meant, sorry. If I said this is the velocity graph, and I said where is speed increasing, then you could get there really quickly by just doing a little doodle of speed. If that's velocity, what does speed look like? Like that, yeah? And so when is speed increasing? There and there, okay. Or you could say, you could go out of it the other way of speed is increasing if velocity and acceleration have same sign. Now that's basically, in this case, it's the velocity is positive because it's above the axis and the acceleration is positive because the slope is positive, or the velocity is negative below the axis and the acceleration is negative. You can get the same answer. A particle is moving toward the origin. This is practically never there for 15 years, and it's been on 2 of the last 4. When is it moving toward the origin? If velocity is positive, what do you need to take into account? Position and movement, right? Because if it's here in a negative position and the velocity is positive, is it moving towards the origin? Yes. So that would be a case of position negative and velocity positive. It's moving toward the origin. What's another case where it would be moving toward the origin? Positive position, negative velocity. So it seems like you could make a rule out of it, but I guess I would like to focus on take position and velocity into account. Okay, and an object is at rest if velocity. Okay. All right. Don't confuse that with a velocity, with an object changes direction. Is that the same? An object changes, sorry, an object's movement changes direction at velocity equals 0? Same thing? When does an object change direction of movement? When velocity changes some. So you'd start by looking at 0, but then you'd say, does it also change? Yes?
So the particle is moving towards the origin if the velocity and position have opposite signs.
It seems like it, yes. So I'm not very good at remembering rules. So if you are, then go for it. But me, I would just remember. I got to remember both to look at both. Okay. All right. Cool. Yay! Let's learn the other half of calculus, shall we? What color is this? Blue. Blue. We got 20 minutes. We can do it. Hey, have a great day, you guys. Some of you, I did. I mean, not many others did. The ones I saw looked great. Here we go. So today is antiderivative / integration technique. My intention was that these would kind of go into a back of a chapter. So, for example, this pre-calc, I would maybe put this at the back of the first chapter in your notebook, kind of as a summary kind of thing. But again, it's up to you. It's your call. So, if you were to summarize antiderivative technique, there actually would usually be 2 chapters for you guys. In a normal calc text, there would be integration techniques, where you learn basic power rule kind of stuff. And then later, like chapter 7, there's usually an advanced integration technique, which is a Calc 2 topic chapter, which you guys know both. So we'll have to cover both. Have a lot to do. Here we go. First of all, the power rule, as you know, is the opposite of the derivative power rule. Instead of bringing the exponent down and reducing by 1, we... What is it? Why are you so quiet? Do you have laryngitis? You're welcome. Anybody else see this book? Okay. You raise the power by 1 and divide by the new, yes? Be careful. Going too fast, you make careless errors. For example, if you were to look at this, would you say the power here is 2/3? No, you would say this power is negative 2/3, so that when you raised it by 1, it becomes x to the 1/3 divided by 1/3, or times 3 is how you would probably write it, which I would too. But wouldn't you agree, you take care to rewrite it sometimes so you don't make some silly error, right? Same deal, be careful not to over-apply the power rule. I think you can agree that this would be nonsense if you said this is x squared plus 1 to the 3rd over 3. That is not true. If I were to check my answer with a derivative, I could verify that that is nonsense, gobbledygook. That's x to the 6th, the derivative of which would be x to the 5th. That's x to the 4th. There's just no way, no way. Okay? So how would you approach that? Think algebra it out. Okay, it'd be x to the 4th plus 2x squared plus 1, and then you'd integrate and cha. Okay? So don't poo-poo the idea of algebra. Log is one of the most common reasons that antiderivatives are muffed. If you have 1 over x, that is the natural log of the absolute value of x, to be sure, but some common errors around natural log. If I throw the antiderivative of natural log, the most commonly chosen distractor is, what do you mean? 1 over x. Okay, now you just found the derivative, not the antiderivative. The actual antiderivative of this requires integration by parts, unless you have it memorized. It requires ultraviolet voodoo is how you do that. And it's actually x natural log of x minus x. Okay? Again, common natural log errors. Don't be that turkey that thinks, oh, it's a fraction, it's log. I mean, is this log of x squared? No, that's ridiculous, okay? Just because you see a fraction doesn't mean every time it's log. That's stupid. You know better than that. It's x to the negative 2, which is negative 1 over x. You get it? And again, it's tempting to say, yeah, it's natural log of sine, but that is 100% not true. It doesn't check. It doesn't work. It's a no. How would you integrate that? I call it cosecant, and then maybe use a recall. What is it? Oh, little rusty. I'll go cosecant minus cotangent and absolute value. All right, Ellie, are you with me? Okay, rules for working with integrals. Derivatives, logs, limits, they all have their own rules for what you can do with them, what you can't do with them. Can you split a sum up into separate integrals? That is 100% allowed. Please do so. Yes. Can you split a product up into separate integrals? That is 100% no. You cannot split a product up. If I have a coefficient, can I move that 3 out front? If I have a coefficient in the argument of a function, like sine of 2x, can that 2 be moved out? Certainly it cannot. It must be dealt with some kind of u-sub process usually, or something akin to it. The 2 cannot be moved. All right? Do not move 2. Okay. Algebra, again, sorry, going back to some algebra ideas. Fraction rules. Can I split a sum in the numerator?
Yes.
You can. This is equal to x over x plus 1 over x. And that is 100% allowed. Can you split a sum in the denominator? 100% not allowed. You cannot do that. Why is that? Just because some math teachers say you can't do that? Or is there a reason? There's a reason. I erased it. Here. Look it over here. Do you agree that 2 plus 3 over 5 equals 2 over 5 plus 3 over 5? Do you agree and say that's a fact? You should. That is a fact. 5 over 5 does equal 5 over 5. What about 5 over 2 plus 3 equal to 5 over 2 plus 5 over 3? Does 1 equal 2 1/2 plus 1 2/3? I think not. So it is 100% not true, not because I say it's not true, I just don't feel like it. It's because numbers don't bear it out. It's a falsehood. If you get an improper integral, improper fraction, not improper integral, excuse me. And by that, I mean the top power is greater than or equal to the bottom power, then you must divide first. So if I got that integral here, then the first thing I would do is divide x plus 2n. I have two division methods, long division and synthetic. Can I use synthetic here? What would you do?
You talk through synthetic.
I what?
Can you talk us through synthetic?
Sure, you bet. So synthetic division is only used when there's a linear divisor. So if I had x cubed over x squared, synthetic division's out. You can't use it. Okay, synthetic division only works when there's a linear divisor. What goes here is not the factor there or the add-in, but the 0. So what's the 0? Negative 2 goes here. What goes up here are the coefficients without change. After that, the process or the algorithm goes, you bring down the first number, and then it's multiply, recorded in the next column, add. So multiply, recorded in the next column, add. Multiply, recorded in the next column, add. Then obviously you need to know what the heck this tells you. You need to be able to interpret this. This is like a matrix or something. It's just stripped down numbers. You need to know where the variables fit in. What does that mean that this integral is equivalent to? I just divided x into x squared. So it's the degree of my answer. X, this is 1x plus 5 minus 6 over x plus 2. The goal being that after that, you can integrate it 1/2 x squared plus 5x minus 6 log of absolute value of x plus 2. And you're rolling. You good? Okay, the last one is a classic finals kind of problem because it requires you to put skills together. How would you approach that last one? Okay, partial fractions would work if you wanted to go imaginary numbers, but I don't want to do that, so never mind on that. Yeah. Split it, yeah. You would split it. Absolutely. And it's really, that's why it's a good finals problem, because it's really two different problems. The first one is what technique? That's use of, which I assume you could do just fine. And the second? It's arctangent. Okay, so arctangent. And we could do the details of that if you want, but I think from there you're probably home. You with me? Okay. Move on. Okay. Memorized anti-derivative is cosine, sine or negative sign? Check it and make sure it makes sense. Is negative sine's derivative cosine? No, and therefore it is not negative sign. It must be positive sign. Always take a second to say, did that work if I took a derivative? Did that work if I took a derivative? Okay, so it's sine. What about sine? Cosine? Does that work if I take a derivative? No, it would be negative sign, so it must be negative cosine. Wait. Okay. Tangent. If you had to show the whole process, it's sine over cosine then u sub, but you should probably have it memorized. It is log of the absolute value of secant. Okay? E to the x is obvious, but it is one of the great trap problems because people tend to oversimplify this and think, oh, anytime you see an e, it's the same. Well, slow yourself for a little second. What about if you have this? Is it 1 over e to the x? No. You would slow yourself down, and how would you approach that classic trap question? I would take a rewrite step. That's either u sub or mental u sub. So what's the antiderivative? It's negative e to the negative x. See, it's not e. Okay? Slow yourself down. This is ultraviolet voodoo if you had to. I think I already got to do this. Sorry. Secant squared. Now that's actually more of a memorized derivative than an antiderivative. What has that derivative? Tangent. So if you know your derivatives, then you'll recognize antiderivatives. What has that as a derivative? Secant. This guy? Arctangent. And this guy? Arcsine. And what's the general approach for absolute value when you integrate? Piecewise. Okay, so this one we do piecewise. Usually, usually you do a definite integral. I don't know what I was thinking. You with me? Okay. U substitution. U sub is obviously, as you might know by now, a huge skill of the calculus. You must know it. If I look at an A/B test, a 45 multiple choice questions, usually 7 or 8 have U sub. For you guys, U sub out of 45 is probably at least 4 still. Maybe it's a big skill of calculus. You've got to have it down cold. Most people know when to use it. The most common case is when you have a product and one is the derivative of the other. Most people see this and they know U sub there, but sometimes students aren't aware of the other use for U sub, and that's maybe what's called the unfortunate sum case. You could do this by ultraviolet voodoo. Students often do it that way, and it's fine. But this is also a U sub case. Do you agree that I can't distribute there because the sum is in a root? But if you U sub this, if you let u equal x plus 1, then it becomes u inside the root, and x is u minus 1 outside the root. And dx and du are the same. Then you can distribute that. So that's another possibility. Something like that. Okay? I forgot to look at my notes here, by the way, but there are a lot of textbooks, and once in a while on the AP test, this U sub is referred to as change of variable. Okay? So if they say use a change of variable to integrate this problem, that's what they're saying, U sub. Okay? This, I think better than this would be this. This is also one of the great common trap problems. It feels like you don't have to use sub it because it's x to the first, but what's the gotcha to that? Yeah, the negative is a huge gotcha there. I would either take into account the negative and be careful, or actually use sub it. So I would, on the AP test, if it were me, I would use sub this. If it was this, 5 over 7 plus x, I'm not going to use that, that's ridiculous. But if there's something funky going on there, you might at least slow yourself down. You with me? Again, actually, I'm just going to make sure. Do you agree that when you choose your u, it's the inside of the composite function, and that sometimes the du requires a little manipulation? Would you agree that the dx in its form doesn't have that pi over 2, so you make this adjustment of moving that pi over 2 so that your substitution would be more like cosine of u 2 over pi du, right? And when you do u sub on an indefinite integral, you sub back. Please sub back. Okay? If there's a definite integral, there's 2 ways to go and 1 way you can't go. You can. It is okay to u sub everything, including the limits. That is, I believe, how you were taught. That's definitely how I was taught. This is good to go. When you do that, you don't sub back. So, for example, if I did this, what would you let u equal? U is it the sine or the cosine? It's the inside of the composite function. The composite is this. This is a function within a function. So you'd let u equal 5 cosine of 2x, and du is, by the derivative of that, negative 10 sine of 2x dx, right? Are you with me? Okay. So that dealing with some of the stuff, the 3 could be moved out front, the negative 10 I'd have to move over, and I'd have 3 over negative 10, and then I could sub with all the stuff that was there, root u du. And then if I u sub with a definite integral, I have to change the limits. If you were to write anywhere in a free response question, a u sub antiderivative or integrand with the old limits, you're out. Okay, it doesn't matter if you sub back later and get the right answer. They don't care. You did terrible calculus. That is in no way true. That is not saying it's terrible calculus. They will nail you for it. This is terrible. So you have two approaches. You either say, I'm not touching the limits. I'm going to find the antiderivative and then evaluate it at the old limits, or you actually use up everything, including the limits. Is that clear?
If you're not going to change the limits, should you just leave it as indefinite?
So if I were going to do this without changing the limits, my work would look something like this. I would find the antiderivative, the degree would be negative 3/10, 2/3 u to the 3/2, which is negative 1/5 5 cosine of 2x to the 3/2, right? My work then would say this is equivalent to negative 1/5. What's going on here? What's that? Oh, yeah, I said that, right? Okay, negative 1/5 5 cosine of 2x to the 3/2 from pi over 4 to sin pi over 4. So they could look here to figure out how I did my antiderivative, but I never once wrote those limits on a u subunit. Yes? Yes, they do. So that integral does come out to be 0. I would imagine, without looking at the graph, it's probably area above and below canceling out kind of thing. Is probably what's going on. Yeah. Okay. Integration by parts. It is minus, please. Ultraviolet voodoo, yes. Ultraviolet voodoo is the mnemonic that helps you remember it. Ultraviolet, UV, minus voodoo. But it doesn't have, the mnemonic doesn't have the minus in it. Don't forget it's subtract, not plus. It's subtraction. Cool? You use it when you have a product, but one is not the derivative of the other. Okay? You'll be happy to know that I have never seen a tabular. Actually, tabular is pretty easy, isn't it? I've never seen a circular. So it's pretty much just straight up ultraviolet voodoo. In choosing the best u is log. The next best u is inverse trig, like arctangent or something if you had it. Then polynomial or algebra, like x to the first or the square root of x or something. Then terrible, we're starting to get into terrible u, is exponential and trig. These are the worst u. Those usually you end up using when you're doing the circular. Okay? If you do this ultraviolet voodoo and your new integral is worse, you chose bad. You chose the wrong u, the wrong u. Okay? You chose badly. Go back and read it. All right. So, for example, here, notice the smallest differences in problems. This versus this, two totally different approaches. Just that one little change. The second one, what's the approach? U sub. But the other one is ultraviolet voodoo. Okay? We'll finish tomorrow. Have a great day. Thank you for coming.